Dear learners, Assalamu alaikum. Welcome you all to this class. Please subscribe to my channel after watching. This will certainly inspire me to do the next video. Our today's topic, linear programming, learning outcomes. Dear learners, at the end of this class, you all will be able to, number one, know the linear programming related terminologies. Number two, express the linear programming model. And finally, number three, determine the extreme value of an objective function. Prior knowledge, a straight line divides a plane into three parts, two half planes and the line itself. If you draw a plane and a line on it, then this line is itself a one part. And on one side of the line is one half plane, and on the other side of it is another half plane. The half plane including the line is called closed half plane. The half plane excluding the line is called open half plane. So the linear inequality of the form ax plus by plus c less than 0 or greater than 0 represents the open half plane, and the linear inequality of the form ax plus by plus c less than or equal to 0 or greater than equal to 0 represents the closed half plane. Ax plus by plus c is equal to 0 is the equation of this straight line. So ax plus by plus c less than 0 or greater than 0 will be any half plane excluding the line, and as well it represents the open half plane. But ax plus by plus c is equal to 0 is included in the linear inequality ax plus by plus c less than or equal to 0 or greater than or equal to 0. That's why it represents the closed half plane. Pictorially, half planes are represented by making shade or parallel stripes, and if line is included with it, the line is represented by a dashed line. Shaded half planes are represented here. Parallel stripes and dashed line should be represented later on within this class. Let us make it clear with the examples. We consider the inequality thrice x plus y minus 15 less than or equal to 0. The corresponding line is thrice x plus y minus 15 is equal to 0. This line passes through the points a50 and b0, 15. This is very simple. Find any two points on a straight line. If you put y is equal to 0, then you will get x is equal to 5. Then one point is 50. So it is denoted by a. And if you put x is equal to 0, then we will get y is equal to 15. And the another point is 0, 15, which is represented by the point B. Assuming the length of one side of the smallest square as 1 unit with respect to the axis x or x prime and y or y prime, we plot the points A50 and B015 on the graph and draw the line AB. Since one square is considered as 1 unit, that's why OA will be the length of 5 smallest squares. And similarly, OB will be the length of 15 smallest squares. However, AB straight line is the graph of the equation 36 plus y minus 15 is equal to 0. But what will be the graph of 36 plus y minus 15 less than 0? The graph of 36 plus y minus 15 less than 0 will be any of the two half planes, excluding the line. We should trace it by applying base test point. Since there is a constant 15.00 is not on this line, that's why the base test point is 00. By applying the point 00, we can write 36 plus y minus 15 is equal to 3.0 plus 0 minus 15 is equal to minus 15. Less than 0. Is less than 0. And in the given inequality is less than 0. Which is relevant. The relation is true. That's why the graph of 36 plus y minus 15 less than 0 will be the half plane containing the origin, containing the point 00. Therefore, we can write the inequality 36 plus y minus 15 less than or equal to 0 represents the line AB and the half plane containing the point 00, which is marked by making shade. Thus, a half plane with the line is a closed half plane. Similarly, we can represent the inequality 36 plus y minus 15 less than 0 as in the following open half plane. This is very much important to remember. Since strictly less than 0, that's why the straight line is excluded from the graph and the line is presented by dashes, or it is a dashed line. Main speech on the topic, linear programming. If you like to give a meaningful, relevant, and organized idea about linear programming, we can say linear programming is a technique of finding the extreme value of linear function over a region specified by linear inequalities expressed in some situation and with limited resources. The inventor of this technique is credited to Russian mathematician Leonid Kantrovich for the development of linear programming problems during the Second World War. In order to make it clear more, we should focus on linear function, region, linear inequalities. We have already discussed that each linear inequality represents the half plane. A set of linear inequalities represents a region. The maximum value or minimum value of linear function lies at the corner points of this region. The technique of finding the maximum or minimum value of the linear function at the corner points of this region is called linear programming. Feasible region. This region is called feasible region. However, we can define it separately. The idea is already expressed before you. The region is specified by the intersection of half planes represented by the linear inequalities of the linear programming problem is called feasible region. Its linear equation represent half planes. Common places of these half planes represent a region. This region is called feasible region. Only next, objective function. The function represented in the linear programming problem is always to be maximized or minimized. It's called objective function. We should explain these terminologies from the practical points of view. Let us see linear programming problem. A merchant can purchase a total of 100 sets of radios and televisions with an amount not exceeding $10,400. The prices of each radio set and television set are $40 and $120 respectively. The profits of each radio set and television set are respectively $16 and $32 respectively. What will be the maximum profit? Linear programming model. Maximize the objective function p is equal to 16x plus 32y under the conditions x plus y less than or equal to 100, x plus thrice y less than or equal to 260, x greater than or equal to 0, and y greater than or equal to 0. Where x is the number of radio sets and y is the number of television sets. Actually, the linear programming problem can be expressed as a linear programming model by following 5 steps. Let us say, let the merchant purchases x sets of radios and y sets of televisions. Also let the total profit be $p. In the first step, we should choose the deciding variable x and y. Since we are asked to find the maximum profit, that's why the profit $p. P is the objective function which is to be maximized. That's why in the second step, this objective function should be expressed mathematically. The profit of one set of radio is $16, so that the profit of x sets of radios is $16x. Similarly, $32y is the profit of y sets of televisions. That's how you can write, since Profits from radio and television sets are 16x and $32y respectively. Therefore, the objective function is P is equal to 16x plus 32y, which is to be maximized. And in the third step, condition should be expressed as the linear inequalities. Since there is a maximum number of 100 sets of radios and televisions, that's why we can write x plus y less than or equal to 100. Again, 40x and $120 respectively, as the cost of one set of radio is $40 and the cost of one set of television is $120, and the total expense cannot exceed $10,400. That's why you can write 40x plus 120y less than or equal to 10,400. Dividing both sides by 40, we can write x plus thrice y less than or equal to 260. And in the fourth step, we should write the variables as non-negative inequality. Let us see. The number of sets cannot be negative. Therefore, we can write x greater than or equal to 0 and y greater than or equal to 0. Dear learners, it is important to remember that if the merchant is compelled to purchase at least 5 sets of radios and 10 sets of televisions, then these 4 steps will not exist, because in either case x will be greater than or equal to 5 and y will be greater than or equal to 10. However, and in the fifth step, you should write the linear programming model or formulate the linear programming problem. Just write the linear programming model. With a practical application, we have shown how a linear programming problem can be made a linear programming model. But in general, let us see the 5 steps. Step 1, choose the necessary deciding variable in accordance with the condition given in the problem. We have done it in step 1. Step 2, choose the function which is to be maximized or minimized and express it as the sum of the products of chosen variables and the constants representing per unit valuation of the corresponding variables. Again, I tell you step 3, from the linear inequalities or equation with the help of chosen variables, related constants, maximum availability or minimum requirements are equal. And step 4, to separate the non-negative factors and express them as non-negative inequality exist. We have done it as x greater than or equal to 0 and y greater than or equal to 0. If it not exist, then it is not required to mention. Step 5, to formulate the linear programming. Let us now find the maximum profit. We are asked to maximize the objective function p is equal to 16x plus 30y under the conditions x plus y less than or equal to 100, x plus thrice y less than or equal to 260, is greater than or equal to 0 and y greater than or equal to 0. Or you may be asked to solve the linear programming problem. However, in either case, we should write the corresponding straight line. Corresponding straight line of this linear inequality is x plus y is equal to 100. Similarly, x plus thrice y is equal to 260. For linear inequality, this second linear inequality. And similarly, x is equal to 0 and y is equal to 0. X is equal to 0, the equation of the y-axis, and y is equal to 0 is the equation of the x-axis. X-axis and y-axis are always drawn in the sheet of graph paper. Now we have to draw these two lines, 1 and 2. Just we have to find two set of points on the lines 1 and 2. If we put y is equal to 0, then we get x is equal to 100, then one point is 100, 0. If we put x is equal to 0, then we'll get y is equal to 100, then the other point is 0, 100. Similarly, find the other 2 points on the line 2. Say line 1 passes through the points A 100, 0 and B 0, 100. And the line 2 passes through the points C 260, 0 and D 0, 86 and 2/3. Line 3 and 4 are respectively the y-axis and x. Assuming the length of one side of the smallest square as 20 units with respect to the axis x, x prime and y, o, y prime, we plot the point A 100, 0. Since 20 units is considered as one smallest square, we divide 100 by 20, we will get, assuming the length of one side of the smallest square as 20 units with respect to the axis x, o, x prime and y, o, y prime. We plot the points A 100, 0. Here 20 units is considered as one smallest square. And if we divide 100 by 20, we'll get 5. That's why we should plot the point A by moving 5 smallest square, 1, 2, 3, 4, 5 along the x-axis. Similarly, plot the point B 0, 100 and C 260, 0 and D 0, 86 and 2/3 on the graph paper, and draw the straight line AB and line CD. Let us now trace the feasible region. First, linear equilibrium. If we put x is equal to 0, y is equal to 0, then it is true. That's why these linear equilibrium represent the half plane containing the origin. Similarly, second linear equilibrium represent the half plane containing the origin. A is greater than or equal to 0 will represent the half plane on the side of y-axis toward the right direction, and y is greater than or equal to 0 represent the half plane toward the upward direction. Thus, we can easily write OAQD is the feasible region. Since AB and CD intersect at the point Q, and Q is the corner point of this feasible region, that's why we have to find this coordinate of this point by solving the equation 1 and 2. The coordinates of the point Q are 20, 80. Since the maximum value of P lie at the corner points of the feasible region, that's why let us find the value of P at these corner points. We observe that corner point xy and P is equal to 16x plus 31. Just this value. At the point 0, 0, the P is 0. At the point 100, 0, P is 1600. At the point Q 2080 is 2880. At the point 0, 86 and 2/3, the value of P is 2773.33. Very clear. The maximum value of P is 2880. That's why the required maximum value of profit P is $2,880. By applying graphical method, we have solved this problem. Except graphical method, we have simplex method, dual simplex method, reverse simplex method, distribution or transportation method, and finally dynamic programming method. However, have you any query? Please write me. It will be considered with utmost importance and be benefited. Thank you very much. No more today. With this, I conclude here.